Bismillahirrahmanirrahim. I'm Shahroz Ali. The topic I choose for this master's thesis is Education Conversation Solutions using Contact Center AI. Dr. Fruki Azam supervised this, and Dr. Aslan Shokat and Dr. Wasi Hyderabad is a GEC member, and Dr. Mohammad Wasim Anwar is the external GEC member of this master thesis. This is a presentation outline. The first one is introduction, second one is literature review, third one is proposed framework, and then implementation, validation, state of art comparison, and in the end, conclusion and future work. Production background. Chatbot is a conversation software system that is designed to emulate the communication capabilities of a human being, then interact automatically with the user. Chatbots applications are classified into four groups. The first one is a service based, in which chatbots are designed to provide service to the customers. A second one is goal based, in which chatbots are designed to achieve some sort of goal based on the conversation history. Third one is knowledge base, in which chatbots are designed to retrieve something from the knowledge base or data sources. And the fourth one is response generated based chatbots, which are basically designed to generate a response on the runtime. Background. The focus of this research is on the response generated based chatbot, which is actually the artificial intelligence approach, which is classified into rule based chatbots. Second one is generative based chatbots, and one is the info retrieval based chatbots, and these are their implementation approaches. Motivation. This master thesis has three motivation. The first one is to get rid of titled system education institution administrative start by automating the answer to frequently asked question. Second one is provide an additional way that will created across multiple channels 24 by 7 to minimize leverage and intervention. And the third one is student do not have to pursue site searching for frequently asked question pages, or on the other hand call the authoritative staff to pose inquiries. Goals and objectives. This master thesis has four objectives. The first one is to explore the purpose and application of chatbots in the education domain. Second one is to identify chatbots approaches that were currently used for the development of chatbots. And the third one is to identify the chatbot platform that were used for development of chatbots. And the fourth one is to design a chatbot named NUBOT to be a proof of concept aiming to assist international local students and NAS, which will be a good additional way for them to get information they are seeking. Literature review. From literature review, we are trying to answer these mentioned research questions. The first one is what is the purpose and application of chatbots in the educational domain. Second one is what is the most potential area in which there is a need of chatbots for future purposes. Third one is what are the chatbots approaches that were currently used for the development of chatbots. And the fourth one is what are the platforms that were used for development of chatbots. Research methodology. The protocol guidelines we adopted for systematic literature review are divided into four steps. The first one is the planning procedure, in which we specify the research questions and search elimination criteria, and specification databases, specification search criteria, identification of search gap will be done. In the second step is conducting procedure, in which specification, searching keyword, section of criteria, data, and quality assurance criteria will be done. Third one is reporting procedure, in which data section will narrow down the potential area, analysis and interpretation of result will be done. This is the overview of our research, in which we utilize the eight databases. From eight databases, we selected the 64 studies, and after high-level classification, we identify the five areas. The first one is teaching and learning. Second one is administrative. Third one is assessment. The fourth one is advisory, and the fifth one is research and development. Our focus over research administrative area, which is our potential area. So we further identify their implementation approaches of chatbot development in it, which is a rule-based approach. Second one is machine learning approach, and third one is deep learning approach. Then we further classify their implementation approaches in it, like pattern matching approach, AML approach, in the rule-based approach, and in machine learning approach we identify implementation approaches, supervised learning approach, and in deep learning approach we identify information retrieval-based approach and generative-based approach in it. Then we perform the qualitative quantitative analysis. From that we identify two chatbot platform, which is the dialog flow platform, and the second one is the Rasa platform. And we also identify most commonly used languages like Python, AML language, which is artificial intelligence markup language, that were used for the development of chatbots in the administrative areas of educational domain. And literature analysis result, this is chatbots areas we identify in the educational domain with respect to their databases. The first one is teaching and learning, second one is administrative, third one is assessment, fourth one is advisory, and the fifth one is research and development. This is the pie chart which shows the chatbots weightage that were current and deployed in the educational domain, which includes teaching and learning 30%, administrative 90%, advisory 11%, assessment 14%, and research and development 26%. From literature view, we identified three implementation approaches that were used in the administrative area of educational domain. The first one is rule-based approach, in which chatbots were designed by searching a question from a pattern matching from a defined rule in knowledge base. Second approach is machine learning approach, in which chatbots are basically designed to extract pattern from data and set over and involve its rule through which instruction manually. Third approach we identify is the deep learning approach. These chatbots have the ability to learn from the representation of data itself, which is also known as a feature engineering approach that will also have the ability to identify data automatically to classify it. Literature review. Here I mentioned some approaches from the previously built chatbots that were used for the in the administrative area of educational domain. The first study is develop the chatbot through the Dialogflow platform, which is a closed source platform, and it utilizes the deep learning approach in it, and also use the simple fallback classifier, and it has accuracy type issue and third party issue. Second one, develop the chatbot through rule based approach, and it also has accuracy issues and domain specificity issues and data pre-processing required in it and fixed rule based type issues. Third, we developed the chatbot through machine learning approach through an AI-biased model, and it also has accuracy issues and domain specificity issues and data pre-processing required in it also. And the fourth one, developed the chatbot through deep learning approach and with the utilization of RASA platform, which is an open source platform, but they utilize the sequence tradition LSSTM model, and also use a simple fallback classifier, and it has no ability to recommend something, and it has also grammatical issues, accuracy type issues. So there is a need of a new chatbot framework in the administrative area of educational domain. The desired chatbot should overcome the above mentioned multiple issues in the previously built chatbot. For this, the development of chatbots, the first thing is the chatbot platform. For this purpose, we perform a chatbot platform selection criteria, which is also important as in respect to the accuracy wise of to generate better results. Based on the usability criteria, we distinguish the available platform in the market into seven different dimensions. The most important dimension is the domain source. As you can see that the above four chatbot platform are the closed source, and last one Rasa is the open source platform, and it also has the ability to easily integrate to the third party service and also outperform here as well. So we decided to go with a Rasa platform to that our which is also a open source platform, or our third party integration issue will be also sorted out, and we can easily deploy our chatbot on the Facebook Messenger, and we can also build custom web based UI as well. And the second thing is the chatbot approach, and the third thing is implementation approach, and the fourth thing is model technique. Chatbot approach, we will use the deep learning approach. Through that, our fixed rule based issue will be sorted out, and there is no data pre-processing required in it. And the implementation approach will be utilizes the hybrid model approach, which is a combination of information and retrieval based model and plus genetic based model. Through that, our accuracy issue will be sorted out, and model technique we will utilize is a BERT model, which is bidirectional encoded representation transformer, and plus DIT classifier, which is dual intent entity transformer, which is sort of transformer learning approach. Through that, our domain specificity issue will be sorted out, and we will utilize the dual fallback classifier, which is our custom made classifier. Through that, the desired chatbot will have ability of self learning, and it has will have also ability of recommend something, and during response generation or recommend something, our grammatical issue will be sorted out. There will be no error during response generation. Proposed framework. This is a newborn architecture. For the training of model, there is a need of training data. For this, the case study utilizes a NUS. Firstly, we list on all the questions and prepare the answer according to it. Our means of information is a NUS website and administrative start of NUS. Primarily, this chatbot supported only two modules: accommodation and admission. To accelerate the cycle of data set generation, we utilize the services of the data set generation framework. We identify the five different framework, and the first four utilize a comparative linguistic structure for composing the layout. So we decided to go with ChatGPT platform for two reasons. It's simple syntax to create the scripts and the Python library support as well to integrate with Rasa. After that, the data simulation is performed, in which a categorization of data is done into 10 examples based on the NUST combination and admission module. And we entered the intents into NLU.md file and along with the example, and we refer it into domain.yfl file for the response generation. And after that, action is created from the conversation action with the prefix utter underscore in the domain.yml file, log in the intents. These are the response generated in the domain.yml file. After that, conversation flow is created in the story.md file. This is the intent and this is the response in the combination make a story. After the creation of a training dataset, the next step is parsing of text into the NLP pipeline, which is performed into two steps. The first one is pre-processing of a text is done, and the processing of a text is done. Let me show it how it's done through the example. For example, the user asks a query about eligibility criteria of NUS. The first step is performance processing is done by passing the text into white space tokenizer, which is responsible for the parting of text into tokens, and then pass the text into profanity analyzer, which is responsible for the sensing of criminal words from the text, such as shit and criminal words, crime from the text. And then featureization of a text is done in the third step, and Rasa basically provide the two type of featureization. And the first one is the dense featureization. Second one is sparse featureization is done for the dense feature extraction from dynamic text. We utilize the pre-trained generative-based bird-based model, which is a bidirection code representation transformer. Let me show the working. Basically, it's both. It's a generator language representation model. It's only user encoder part. The input is to be encoder for a byte sequence of token, which are first converted into vector and then processed into the network through the attention mechanism. And it consists of a 12 layers and 760 hidden nodes and 12 attention heads along with the 110 million parameters. Firstly, the tokenized text is passed to the bud and it performs three layer of embedding. The first layer token embedding in which and CLS token, which is sentence level classification token is passed in the start of text and separator token is passed in the end of sentence and segment embedding is performed, which indicate each sentence with the alphabetic in the form and with the alphabetic number like A means the first sentence and B means the second sentence, and the position of banding is performed, which is responsible for for the indicating of tokens in the sequence of word. And then the criteria of working of word model is a mass LM criteria, MLM criteria, and in which word actually mass the word randomly in the sentence and then try to predict them based on the context provided by the other non-mass word in the sequence, and pass it through the 12-layer encoded layer through masked language modeling ahead and categorize the criteria as a masked word. Masking means the board model looks in both direction and shows the full context of the sentence, both left and right surrounding in order to predict the masked word. After test feature extraction from the text bar, feature extraction is done for the visualizer 3 featureizer. The first one is the Raja featureizer, which is uh, which is working principle is regular act as a regular expression and identify the number, date, and time in the specified format from the number text, and then Lexit synthetic featurizer is utilized in it, which is responsible for the character identification of character and grams and building the token as a document as a sequence of character. Then count vector featurizer is utilized in it now for the bag of word creation. Let me show you the working of sparse feature extraction from the example. And this is our eligibility criteria of NUST. Text is passed by the user. Firstly, is pass it through the white space tokenizer. If we part to tokens, and the count vector feature as well is work activated, which is responsible for the creation of spar matrix sequence of features and the dimension of with the 2 cross 25 dimension array, and Lexus center feature as well will be activated after that, which will enhance the spar feature into 125 dimensions to provide the more information to our model. After the spar feature extraction and the dense feature extraction from the text, one hot coating is applied on it, and the vectorization of an based text is done. After that, this vector of sequence of sentence is passed to the dice classifier for the identification of intended entity from the text. Let me show you the internal working of the dot classifier. This is our custom type classifier, which is dual-intent entity transformer. Firstly, the tokenized word is passed to from the sequence is passed to the type classifier, and it will extract the sparse features and the pre-trained embedding, which is a dense feature from the BERT model at the same time, and passes through the feed-forward neural network, which is fully connected convolution neural network responsible for it will generate a complete array of 256 dimension array, and the processor token pass it to the two layers of transformer, which is responsible for the output in the form of intent and entity extraction. And for the intent classification from the text, an embedding layer, similarity layer, and intent loss function is responsible for it. And for the embedding layer is basically responsible for the generation of loss function between the predictive intent by the output of the transformer, and the similarity layer is responsible for checking checking the input of two embedding layers, and intent loss function is activated to calculate the loss between the output of the transformer and classification of a sentence, and allow the model to learn it through gradient descent, and after through that it will be able to identify the intent in the form of a definition for this text. After identification of intent, and the second thing is the entity extraction. For this, entity loss function will be activated along with the CRF classifier, which is the condition and field classifier, which responsible for this prediction of structural label from a single sentence without considering the neighboring samples, and identify with the help of entity loss function identify the entity NUS token as the form of organization. After the intent classification and entity extraction with the confidence 0.7 and 0.9123, the test is passed it through the processing pipeline, in which we utilize the three policies. The first one is based on the confidence level achieved by the intent. If the confidence level of intent is equal to 1.0, memorization will be or policy will be activated, and the physical response will be generated according to it. If the confidence level score is less than equal to 0.3, then the two-stage fallback policy will be activated, and it will check the it will recommend the user, for example, what type of text is required for the admission address. This is the query entered by the user, but the bot will be not able to recognize it in the well form. Then it will recommend based on the previously clear intent in the form of admission schedule. Do you mean by the admission schedule, and give the yes or no options to the user. If the user enter no, then it will suggest or recommend the user again phrase text again, then the user enter in the return of modified text, and the response will be generated if the bot will understand this sentence in return of it. If the confidence score is less than 1.0, then transformer embedding dialog policy will be activated, which is the introduction transformer will take care of previous system action slots, which is the bot memory and the user intent entities, and the utilization of embedding layers and similarity layers, and action system action will be performed on it and predict the next actions. Listen intent admission with a confidence of 0.91, and the response is generated in a return of 8. Chatbot also has the ability to generate inferable based response by interacting with the MySQL DB. And let me show it through the example. For example, user receive a text, and firstly it will analyze and invest text and check whether any instruction required from the user intent. is not or yes. If chatbot not be able to answer the inquiry, the simple intent false will be called. If yes, then it will check it's an info-retrieval based intent or a non-info-retrieval based intent. If a no, then generate a fixed and changeable response. If yes, then it will interact the MySQL DB. For example, the user want to check the details of their registration. The bot will ask about registration number and the query will be generated in the backend in the form of select from accommodation data where registration equal to 19988 and then it will retrieve the information from the DB in the time of it and display it to the user. For a deployment point of view, we deployed our chatbot only to distribution channel in the implementation. Rasa platform has the ability to easily integrate into third-party services such as Facebook Messenger and Twitter, and for this we utilize it into or deploy it on our two platform. In the first one is we develop a custom UI and Facebook Messenger and integrated with Rasa platform. This is the application architecture of our custom web user interface. We develop the web front end through the HTML, CSS, JavaScript libraries, and the web backend through Flask Python framework. And the Exchange Flow APIs is called to get and post call requests between web front end and web backend, and it will also get requests from Rasa platform with the utilization of Socket.ai library, and it also we also integrate our Rasa platform through webhook with the MySQL DB for the info retrieval based response generation, and this is our custom web user interface of a new bot. For the deployment of our chatbots in the Facebook Messenger. For this, we firstly create a Facebook page of on Facebook's, and then Facebook for developer account is created on it by the utilization of Facebook developer account services, and through that secret key and the page access token is created, and we uh, call the webhook callback through the ngrok Python library, which is responsible for the creation of a virtual IP which allows the communication between the Rasa server and the Facebook Messenger app. This is a new bot Facebook Messenger UI, which allows the user of Facebook to interact with the chatbot as for a normal user of this new social network area. Validation. Evaluate model, a huge customized dataset we made for this, which consists of a number of intent 108 with almost 4 to 63 examples. And then we perform a data validation by splitting 80 by dataset into 80 by 20 split ratio using the RASA data split command. NLU command. The purpose of this is to check there is no conflict between the stories and NLU .md and to method by any file. You can clearly say that there is no conflict between the stories and our files. Then the performance of intent classification is done in the form of intent conversion matrix, which obtained by the utilization of rasa test command inside the CLS, which gives the accessibility to run the test on NLU encode data of model. The vertical axis shows the true label intents, and the horizontal axis shows the predictive intents, and their point of intersection lie on the diagonal axis, which shows that. And the predictive true label intents correctly classify the predictive intents, and while the rest of fly went below the diagonal line. Then this is the intent prediction confidence distribution, which shows the hits and missing of our intents, and you can clearly see that our model successfully predicted each every intent with a confidence score of roughly 0.98 to 0.99. And this is the training dataset results we achieve with the prediction rate of 0.98 to 0.99 and we got the accuracy of the 99.64, we see 98.57, equal 98.7%, equals score is 98.61%. Then we perform the model testing based on seen data. For this we pass a test set of 50 examples to our model. This is test soup. We pass it to our model. This is the action conversion matrix generated into a return of 8. You can clearly see that from the conversion matrix graph. And 3 out of 53 were misclassified by our model, while the rest of lie on the diagonal line. This is our model testing results. The report log shows that we performed the end-to-end level testing on our 50 tests of training test data set. Out of 40, 50, 47 were classified by our model, and we performed the action level testing that at the same time on the available data set, and which is 100 attempts available for it, and 96 were classified by our model correctly. This is a confusion matrix for the understanding of how end-to-end level and action level testing will perform. Firstly, it will check the test data set and identify the and intent from it, in which 47 were correctly classified, 3 were misclassified by which is out of scope of the bot, and then it will check the already available intents in. Which is 100, and it will perform the uh, uh, predicted 96 intent correctly, and forward misclassified by which is out of scope, and their ratio between two test set and the already available data set is 0.02, and the error rate we got it is 0.04, and through that we achieved the average accuracy of under 0.04 96%. You can clearly see it on the action level testing report as well. And then the precision we calculated it through by true positive divided by true positive plus false positive, and 140 three were correctly identified by our model out of 150, and we achieve a precision 95%. The recall we achieved it. The available positive examples is 100, and the 96 were correctly classified by our model. The 96% recall we achieved, and the performance score we achieved got it is 94%, and you can clearly see it on the graph as well. And this is the performance matrix results we achieve through it. Then after that we perform a state-of-art comparison as well to check the credibility criteria of our model. We perform a state-of-art comparison, and for this we utilize the dataset as mentioned in the paper from the GitHub. The dataset basically consists of data modules that remove the administrative related tasks of their university, and we loaded this dataset into Rasa project. And the dataset basically consists of 27,430 sample examples, and we provide the same environment for the specification of point of view. We provide the same backend, same front-end programming language version Python 3.76, and same compiler PyCharm we utilize for it that we use for development of our chatbot. And the author also provide the 121 test example in their test set, and we pass the same test sample to our model to check its credibility of our proposed methodology and the action conversion metrics in return we obtain through it. And the result, this is the result report we obtained. We performed the end-to-end level testing, action level testing as well. You can clearly see that 121 test satisfactory passed to it out of 178 were correctly identified by our model, and action level testing after performed. And you can clearly see that out of 229 attempts, 182 were correctly classified by our model, and we got the average accuracy of 76.2%, the error rate of 23.8, and precision 83.7. The call is 79.1, and the F1 score we achieve is 77.7%. This is a high comparison results between the state-of-art chatbots and the proposed methodology concept chatbot. And the already existing state-of-art chatbot got the accuracy with their proposed methodology 73.7%, while our proposed proof of concept methodology got 76.2% accuracy with the same test data set we passed to it, and its precision F1 score and call score is also outperformed with respect to the already existing result achieved by state-of-art chatbot, which shows that our proposed approach is far better than the existing state-of-art chatbot. Conclusion: future work. In this master thesis, we successfully explore the chatbot application, identify areas in the educational domains, and we successfully explore the chatbot platform and explore the chatbot's approaches as well. And we design a proof of concept chatbot named NUBOT for Nest as well. For implementation point of view, hybrid model approach utilizes a which combination of input-driven and generative-based neural network, and through that accuracy is also enhanced, and grammatical issue will also be sorted out with the utilization of word model generative-based approach. And we utilize the open source platform, which replaces the other proprietary platform like Dialogflow in it, and it also have a self-learning ability as well to recommend user based on the conversation flow on the previous history of conversation with that user. And this chatbot also sort out the application issue as well by have ability to with the utilization of Socket.ai to easily configure with the Flask API for deployment of chatbot on the web and social media platform. And it utilizes a deep learning approach which get rid of overcome the issues of manual feature extraction issues in the ML approach, and overcome the also issues of rule base in the rule based approach, and domain specificity issues will also be sorted out through it by the utilization of transfer learning approach. Through that, this chatbot will be able to run on any NL based data set, make it data driven as well. From a future work point of view, the first potential area is the utilization of more comprehensive pre-trained model like GPT-2 or GPT-3 in the hyper model approach, which will be able to enhance the intent classification accuracy of this model as well. And for the handling of complex queries like aggregated data from the database, there is a need of automated SQL query generation through NLP concept in it, which is able to create a group by and having clause like queries, which is more complex query to enhance and increase the efficiency of chatbot for retrieval point of view. From scalability point of view is also and most potential area. It is also not easy to cover a large scope of topics, so there is a need of a solution to create a chatbot per topic in your organization, and the network is another potential area. This is currently you can see that info-driven approach is done here, and this is recommendation based on the ambiguous input entered by the user, and the self-learning ability also, and there is no grammatical issue during response generation on the runtime. This is a phase of Messenger UI. This is a desktop version. You can also use it through the phase of Messenger UI or mobile version here. Question and answer.